Next, let us see new topic, that is prime and composite numbers. So, what do you mean by prime numbers, children? Prime numbers are unique numbers. So, before that, we are familiar with factors of a number and multiples of a number, right? So, if we consider one table, number of factors, this is okay. If we consider this table, so let us find the numbers till 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So till 12 let us find, okay, the factors. So the factors of 1 is 1, factors of 2 is 1 and 2, factors of 3 is 1 and 3, factors of 4 are 1, 2, 4, factors of 5 are 1 and 5, factors of 6 are 1, 2, 3, 6, factors of 7 are 1 and 7. How am I writing these factors, children? Same as the previous method. Just if 6 is divisible by 2 tables, first see, next see whether it's divisible by 3, next 4, next 6. Like that only, based on that I'm writing these factors, okay. 8 tables, 8, which and all tables it's divisible, 1, 2, 4, 8. Next 9, 1, 3, 9. Next 10, 1, 2, 5, 10. Next 11, 1 and 11. Next 12, 1, 2, 3, 4, 6 and 12. So these are the factors we have with these numbers, right? So number of factors in each number, how many we have? In this we have only one number. In this we have 2. Next 1, 2. 2 numbers we have 1, 2, 3. 3 we have 1, 2. 2 we have 1, 2, 3, 4. 4 number 2. 2, 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4, 5, 6. So these number of factors we have with these numbers, right? So here we can see that number 1 as the factor of only one as the factor, right? So we have only one factor with 1. So here we have 1. For number 1 we have only 1 as the factor, that is we have 1 as the factor of 1 itself. So we can tell that the number of a number 1 has its own factor itself, right? So there are some numbers we have which have factors, number of factors which has 2, right? The numbers which has 2 factors are which and all, children? 2 factor numbers are 1, 2, 3, 4. So these many numbers have factor 2 factors, right? These as 2 factors. because we have two numbers, right? We have with 2, 3, 5, 7, 11, we have two factors. For one, we have one factor. Next, for two factors, we have 2, 3, 5, 7, 11, right? So, these numbers which has factor with one number and two as the number of factors is called as prime numbers. Okay. That is the number other than 1 whose only factors are 1 and the number itself are called as prime factors. That is the only one as a number of its own factor. That is one only it has, right? So we can consider 1 also as a prime number. So what are the prime numbers we got here? We got 2, 3, 5, 7, 11. We can tell as the prime number. Okay. And we can also tell 1 as the prime number because 1 has its own factor. So 1 has its factor itself. So we can tell it is also a prime number. Okay. You can try to find some more prime numbers after 12 also. Okay. After 12 you find the factors of 13. 13 factors you find. So if you add two numbers, number of factors is 2. If that number of factors is 2, then you can consider that number as the prime number. Okay. Then next check for 14. 14 you write the factors. What and all factors are there for 14? If you get number of factors is 2, then you can consider that as a prime number. Otherwise, you don't need to consider that as a prime number. Okay. So except 2, 3, 5, 7, 11 that has number of factors too, we have more number of factors, right? So here we have 3, 4, 4, 3, 4, 6. So we have 4 with number 4, 6, 8, 9, 10, 12 with the number of factors is more, right? So if the number of factors is more than 2, you can tell as it is a composite numbers. Okay. If number of factors is equal to 2, you can tell it as it is a prime number. If the number of factors is more than 2, for a particular numbers you can tell it as a composite numbers. Understood, children? Here as we have 3 is greater than 2, so we can tell 4 is a composite number. Okay. For 6 we have number of factors is 4, so it's greater than 2, so we can tell it as a composite numbers. Understood, children? What is the difference between prime numbers and composite numbers? So this is how you find the prime numbers and composite numbers. Okay. So numbers having more than 2 factors are called as composite numbers. So here one can be considered as neither a composite number or prime number. It can be both. Okay. So we can also find few more composite numbers, like finding the factors of the number. If the factors of the number of factors are more than 2, you can consider it as a composite number. If it is equal to 2, you can tell it as a prime number. So you can find few more numbers and find whether it's a composite number or not. Okay, so without actually checking the factors of the number also, we can find whether it's a prime number or composite number. The method, the easy method, we'll find by identifying the whether it's a prime or composite number without finding the factors is this method. So that method is called as, so that method was given by Greek mathematician called Eratosthenes. So in the 3rd century BC, okay, he is the person who found that method. Without finding the factors of the numbers also, we can find the prime and composite numbers. So let us see how did he find that method and how did he find the prime and composite numbers without finding the factors of a numbers. Okay, so let us see that method. So he founded the prime numbers and composite numbers from 1 to 100. Okay, so let us write the numbers from 1 to 100. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 45, 46, 47, 48, 49, 50. So let me find till 70. Okay. So what did he do first? 1 is not a prime number or a composite number, because only if we have the number of factors equal to 2, we can tell it's a prime number, and if the number of factors is greater than 2, we can tell it's a composite number. So 1 is neither a prime number or composite number, means 1 is not a prime number or a composite number. Okay, so we'll neglect 1. Okay. So let's mark all 2 multiples of 2 except 2. Okay, except 2, we'll cross out all multiples of 2. So first we'll cross out means we'll put into mark. we'll cross out all multiples of 2. So 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 fives are 10. So you can cross out all multiples of 2. That is, multiples of 2 or alternate number. You can leave one alternate number and cross other numbers. Okay. So this and all will be a multiples of 2, children. Because if you multiply 2 11s are 11, 2s are will be 22. So we are crossed out. So 12 2s are will be 24. So we have crossed out 24. That only it goes on. So we'll cross the alternate numbers. Leave one number and cross other number. Okay. For your reference, I'm telling. Okay. So first you'll cross 1 because 1 is neither a prime number or composite number. Next, you will cross out all multiples of 2 except 2. 2 you have to circle. You have to cross out all multiples of 2. Okay. Next, next number we have is 3. 3 is not cancelled, right? We have 3. So now you should cross out all multiples of 3 except 3. Okay. Now cross out all multiples of 3. So 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12. 12 is already crossed out. No need to cross out again. Next, 12 fives are 15, 12 six are 18, 12 3 6 are 18, 3 sevens are 21, 3 eights are 24, 3 nines are 27, 3 tens are 30. Next, 3 tables. Come on. Next, 3 11s are 33, 3 12s are 36, 3 13s are 39, 3 14s are 42. If you don't know the tables, you can put like this and multiply and see. Okay. So 3 15s are 45. You can do normal calculation and see. Okay. Next, 3 15s are 45. Next, 3 16s are 48. 3 7s are 51. 3 18s are 54. 54 is already done. So 3 19s are 57. 57, then 60. Okay. Next, 3 21s are 3 21s 3 21s 3 21s are 3 21s 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 3 21 21 3s are 3 2s are 6, 63. Next 22 3s are 3 2s are 6 6 36. 66 is already done. Then 23 4s are 23 3s are 69. So till 70 let us find. Okay, like that only you have to do. Next, after crossing all multiples of 3, next uncrossed number is what? 4 is crossed, don't need to consider that. Next is we have 5. So in 5, except 5, don't consider 5, except that you cross all the multiples of 5. So 5 multiples of 5 ones are 5, 5 twos are 10, 5 threes are 15, 5 fours are 20, 5 fives are 25, 5 six are 30, 5 sevens are 35, 5 are 40, 45, 50, 55, 60, then 65, 70. Okay. Now we have crossed all multiples of 5. Next, which number we have? Left out number is 7. So you circle 7. Now what you have to do? Same method. You have to cross all multiples of 7. So 7 twos are 14, 7 threes are 21. So 21 is already done. Leave. Then 7 fours are 28. 7 fives are 35. 7 six are 42. 7 sevens are 48. Sorry, 7 sevens are 49. 7 eights are 56. 7 nines are 63. 63 is already done. Then 7 tens are 70. Right? Till 70 we have wrote. Next number which we have, see, 1, 2 is done, 3, 5, 6 is done. Then we have all cross number. Next you see which number we have, 11. So you have to cross out all multiples of 11. So multiples of 11 are 11 ones are 11, 11 twos are 22, 11 threes are 33, 11 fours are 44, 11 fives are 55, 11 six are 66, 11 sevens are 77. Like that only you have to cross all the numbers, multiples of 11. Okay. Next number we have is 13. Right? Next number is 13. So same step. You will cross out all multiples of 13. 13 ones are 13, 13 twos are 36, like that only. So the leftover numbers you can tell it as continue this process. So it will be continuing. So the leftover numbers you can tell that it is a prime numbers. Okay. Because after 7 you don't need to consider for 11, 13 and all. Okay, don't need to check for 11, 13 and all. It's enough till 7. The leftover numbers after 7, that and all numbers are considered as the prime numbers. So leftover numbers are 43, 47, 53, 67, 61. So these numbers are considered as a prime numbers. Okay. So the circled numbers are called as prime numbers, and all crossed numbers, see, crossed numbers are called as composite numbers. Okay. So this method is called as sieve of erraticis. So this method of finding the prime and composite numbers are called as erraticis. sieve of Erathesis. So finding the prime numbers by this method, you call it as sieve of Erathesis. Who founded this method, children? Greek mathematician called Erathesis found this method. Okay. So here the circle numbers are called as prime numbers, that is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. Circle numbers, rest and all you can consider that numbers are called as prime numbers, and cross numbers are called as composite numbers. Okay.